3, 4 is transformations of cubic and quartic functions. Now, the same transformation rules that we've done before about the vertical, horizontal shifts, translations, stretches, all of that stuff still holds true. So when you look at this, the first thing that you always do is say, what's the parent function? And the parent function for this is x cubed. Right? So you always say, okay, what's the parent function? And we have this. So we know it has to be applied to y equals x cubed. Now, they saved the x cubed and the x to the fourth for this year instead of last year for kind of various reasons. But one thing that you can do with this is, and I'm going to show you in this example, is do a little bit of simplification. So the first thing I would do, always, 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 whenever you get any of these guys here, is that you always factor this. Okay, so you look at your parent function and say, okay, I know it's the cubic, but within that bracket, just like what we had with the x squared, right, you kind of look at it and go, okay, I always have to common factor that first coefficient out. Whether it's a negative, a 2, a 1/2, whatever it is, you have to factor that out. That was always our first step. Okay, so then we're going to do that. We're going to say, okay, y equals -8, and you're going to factor out that first coefficient. So it's 1/2 bracket. And then you go for this factor here. If you're factoring out 1/2, you're dividing by the 1/2. You're taking it out. So when you divide out, you go x. 1 divided by 1/2 is actually 2. You can do that on a calculator. You think about that in your head. 1 divided by halves, you get 2 of them. When you check it, you can kind of check it in your head as well. You can go 1/2 times 2. So when you do the distributive, 1/2 times 2 gives you the 1. Right? So whenever you're factoring, you are always dividing by the coefficient, right? So that 1 divided by the 1/2 gives me 2. So over here, what else can we do? So we're going to work with it this way, and I'm going to describe all the transformations. So this says describe the transformations to graph it, and then we're going to graph it. I'm going to show you a little trick with this, though. Okay, so let's describe it first. Everything outside here is vertical, right? I have 2 verticals here, and then I also have a vertical here. Okay? Everything inside of that bracket, just like what we did before, everything here is horizontal. So I have 2 horizontal ones here, 1, 2, and then 1, 2, 3 verticals, right? So 1, 2, 3, there's a -8, and then -3. Make sense? All right, so then let's do this, and we're going to list it. So this will be, I like to list it in order, right? So as you're going left to right, and then I always keep the translations last. So this will be vertical reflection in the x-axis. Okay, this will also be a vertical, and this will be a stretch by a factor of 8. Okay. Then I'm moving to the 2 horizontals here. So this will be a horizontal, and that'll be a stretch, and it's by a factor of 2. So remember, that's always the reciprocal. And then the next one is a horizontal, and it'll be translation. So you can use the word translation or shift. Okay, we're trying to use the math words, and you have to know them. So sometimes we describe it and you draw it, or we ask you to describe it backwards or forwards. So translation or shift, and this will be left 2. Okay, and then for the last one here, this will be a vertical, and that will be translation or shift, and it's down 3. All right, so those are my vertical, horizontal, and we're going to do this. Now, there are 2 ways to do this. One way is to go ahead and use all this and then do our times 8 and such. You can see already times 8 is going to stretch it, and it's probably going to be off the graph. You're going to be like, huh, these points are really, really big as soon as you multiply something by 8, right? Because as soon as we do anything by 8, can I show you something to make your life a tiny bit easier? And again, you'll right away ask, why didn't you show us this last year? And I'll explain that in a second. But when I take a look at this, and I have a common factor of 1/2 here, right? So I have a common factor of 1/2. if I was to say to you, 8 1/2 x plus 2, I've got the negative 8 there, okay? Can I simplify that? So I know there's a minus 3, I'm just ignoring it for now. How can I simplify that? Yeah.
Just multiply, like do the 1/2 to the power of 3 and take it out?
Yes. Each one of those terms gets the power of 3, right? And it's weird to see with the binomial, but each one of them. So then if I was to do that, okay, so that's what I'm going to ask you to do here. So you can simplify. So I'm just going to put a note down. So you can simplify. So you are allowed to simplify a little before you start working with your transformations. So this will be negative 8, right? So I'm going to do this 1, this 3 goes to the 1/2, and it also goes to this. So that would make it, and look at how much easier this is going to become, 1/2 to the power of 3, right? And then the rest of it stays the same, x plus 2 to the power of 3, and the minus 3 just stays out here. We're good? Okay. Then, if you do this, what's 1/2 to the power of 3? 1/8. And then you're left with still this part here, still stays the same. Minus 3. Can you do one more simplification? Yeah. Okay, what's negative 8 times 1/8? Negative 1. And then you're left with still this horizontal. So you might go, but then didn't you just cancel your horizontal, what do we call it, stretch by a factor of 2? So if you have a graph and you are pulling it horizontally, but someone else is pulling it vertically, you're evening it out, right? So if I'm pulling it this way and you're pulling it this way, we're both pulling it and basically it's staying the same shape. We're canceling each other out. That's what this does, is that the 8 here, the stretch that you're pulling here, is actually canceling with the horizontal, so you're at an impasse. This will only work, this simplification. I mean, it works for anything, but the only time it comes in handy is when these numbers can cancel out a bit. Like if this was a 4 and an 8, you can make it 1/2. If this was a 7 and an 8, there's nothing, it's still a vertical stretch by 7 and a horizontal, like nothing will help. So it's only when those two numbers can be simplified a bit. So you kind of look ahead and go, wait, 3 1/2 I can cancel. If this was a 5, it's not going to help you, right? Just leave it inside. Multiplying the horizontally by 5 is easier than doing over 125. Like taking it out would just be worse, right? So look ahead. Why didn't we do this last year when we had functions? We could have. We actually could have. So I had one student who was answering something in their grade 11 class, and she did a 1/2 and a 1/2, and I'm like, but those cancel out because you had a vertical stretch by a 2 and a horizontal compression by, and they actually canceled. She did by accident, so I showed it. But normally last year, everyone just kept them separate and never looked to simplify it. You could have done it last year with any of the quadratics. You could have been like, but wait, if I cancel them both, it ends up being so it ends up being easier. But we just didn't show it to you because, again, we had 7 new functions last year. It's kind of hard to say, hey, you can also do this. But this year, now you know a bit more. The transformations is not new, like this isn't new. So now we're adding the fact that when you can, you want to look ahead and say, would this help to simplify? You don't want to simplify every time. Like I said, if this is 1/5, and you put 1/125, you've just made your life worse, right? So multiplying by 5 horizontally versus multiplying by 1/100, way worse. So you want to look and say, oh, mathematically, that would help me versus not help me. Okay, so that's much easier. So when you do your chart, okay, so when you do your chart to find your points, this chart is much easier. I'll show you what it looks like if you did it the other way. So if you did it the other way, it still works, but the numbers are much, much bigger. Okay, so let's try this one, which we'll see is much easier, and will work out the same way. It's just that the numbers are much bigger on the other one. So here, so this one here, horizontally, all I have is x minus 2. And oh yes, the second part of the question would be, would that switch this? Yes. So if I read this, I'd be like, yeah, that's all perfect. Then over here, you simplified it. That's still okay, right? Because this is still true. You're stretching it by a factor of 8 and horizontally by a factor of 2. They end up canceling. So you don't have to go back and fix your sentence. I'll be like, oh, you realized after. But if your sentence also says it's there's neither one of these. Like if you canceled out both of those, and I went, oh, that's fine too, because technically those two cancel out. Okay, so if you did the answer for this part first and then realized, I would still mark this as correct because those two, this 8 and the 2, are correct. If you did this and then did your words and you missed them completely, I would still mark that correct because technically those two canceled out. Okay, so if you do one or the other first, don't go back and correct it. It's fine. Okay, they're both correct. It's just that one's been simplified now. Does that make sense? Okay, so my points here, this would just be a shift to the left 2. And then here, for y, it would be negative y minus 3. When I get my points, now let me show you what my original points are. My original points would be negative 2 cubed. Remember, this is just y equals x cubed. That's my parent function. So negative 2 cubed would be negative 8. Negative 1 cubed would be negative 1. 0 is 0. Okay, 1 is 1, and 2 is 8. So when I do my graph, I'm going to move it all the way up here. I'm just putting this somewhere in the middle-ish. Okay, I don't know where it's perfect, but I should have put the axis for us, but somewhere in the middle-ish. And then we'll see what we can fit. Okay, so when I put my points in, negative 2, this would give me negative 4. Negatives will be 5. Negative 3, negative 2, 0 is negative 2, negative 3, negative 1, negative 4, 2 minus 2 is 0, negative 11. Okay, so remember that this center part, oh, sorry, let me show you the parent function. So the parent function is this. Do it here. The parent function is 0, 0, 1, 1, and when you have 2 cubed, it jumps all the way 8. 2, 4, 6, 7, so it's somewhere over here. I'm going to miss a little bit. Okay, and then negative 1 and negative 8, 2, 4, 6, 8. So this is y equals x cubed. So remember, it's like a parabola, so half of it looks like a parabola, and the other half of the parabola got split down because it's negative. So that's the parent function. Again, that's, you start with that. You don't have to graph it, but you have to know where the points are. Okay? And again, if you don't need to do the chart anymore, you can go right ahead and do the graph. Right? Sometimes by grade 12, some people are like, I don't need to do the chart. I actually graph it and I flip it in my head. That's fine, but if you like the chart, do the chart. So I'm going to plot this. So it's negative, oh, here. My center point, look up just for a sec. My center point here is still my center point here. So I like to start with that point so I know one side will be heading up or down and the other side is symmetrical on the other side. So start here, negative 2, negative 3, negative 2, negative 3. That's my center point. So that's center point here. Negative 3, negative 2. So I'll go negative 3, negative 2, which is here. Okay, and then here, negative 4. Does this work? I feel like I'm missing a point. Negative 4, 5, negative 3, negative 2, negative 4 should be up here at 5. Yep. 2, 3, 4, 5 there. 2, 3, 4, 5, negative 4, 5. Negative 1 is at negative 2, 4. And then at 0, it's negative 11, which is off the scale somewhere here. So you can see that side does swing up here, so that's going to be nice. Like that. And that's my center point. So I like to start with my center point so I can kind of see the shape forming. So where possible, try to simplify. Okay, that's kind of what you want to look at. Where possible. Not every time will be possible for sure, but if the numbers will cancel a bit, it does make your life easier. I'm going to show you what happens if you use the 8. Right? If you left the 8 where it was, you would still get a graph. It's just harder because the points are right off of it. Like, just they go so big so fast. And I'll give you marks. It's just that I might ding you a little bit and say, but you could have simplified. And look, your graph is very vague because you didn't have very many points on it. So I might take a half mark and say, you know what, you should have tried to simplify. It's not wrong, but look what happens. So I showed the other class as well. We did 2 charts. I won't make you do the second chart, but I did the other chart. Look, when I put in 2, 8, it went all the way to negative 67. And then I put in negative 2, I got 61. The middle term was missing because I did a double stretch on it. So when I graphed it, I only had 2 points. I had this point and this point only, and then these, I couldn't get this one because it got stretched out so far, and this one got stretched out so far. So I only had 2 points, so it made it really hard to graph because I'm like, I have 2 points. That was it. Okay, because it pulled them so far away. If you did a half, then you would have gotten one of the middle points because it would have been stretched as much, but it's just then you're going into fractions, right? So it makes your life a lot harder because I only got, look, 67. It went so big so fast. It's right. It's just so far off, right? So then you kind of look and go, wait, is there something I could have done to make it better? And then I showed them, look, if you had simplified first, your numbers stay better, right? Stay a little bit more contained, right? So that's also a clue. Kind of look at it and go, is there a better way? Or are my numbers getting really funny and I can't fix it, or can I? Okay? That's any questions with that?